On here, I'm going to go through the test number 1 review questions. So follow along. Skip any if you already know how to do it, or just watch it if you want to double check yourself. So the first question says, to which subsets of numbers does negative 30 over 3 belong? Well, the first thing you're going to need to do is you need to convert that fraction into a decimal. And to do so, you're going to divide. So if we divide, you can either set it up and divide it, or just think 30 divided by 3 is 10, put that negative on there, so you'd have negative 10. Now, which is the most appropriate group for it to fit in on the graph here, or the diagram? So you think, would negative 10 be a natural number? No, because natural numbers are your counting. Would negative 10 be a whole number? No, because those are your natural numbers and 0. Would negative 10 be an integer? Well, that's the set of whole numbers and their opposites. So yes, negative 10 would fit in the integers. So if it fits in integers, then it would also be a rational number. So looking at those answer choices, we want to see the one that says it is an integer and also a rational number. That would be B. All right, next question. Number 2, which Venn diagram best represents the relationship among integers, natural numbers, rational numbers, and whole numbers? So if you refer to your digital math notebook underneath your number sets notes, the diagram I have here on the slide is what you would see. So it goes natural numbers in the very inside, whole numbers, integers, rational. So looking at these pictures, we want natural numbers to be the innermost shape. So that one's natural, so that might be the answer. This one says whole numbers, so since that one says whole numbers in the middle, that's no good. The next one we have is, this one says whole numbers also, so we don't want that one. And then the last answer choice starts with natural. Now let's look more closely. Which one says natural numbers, then goes out to whole numbers, then out to integers, then out to rationals? So this one goes natural, whole, rational, integer. These two are flipped around, so that will not be your answer. Now let's just double check on this last one that it is correct and we didn't make a mistake. Natural numbers, whole numbers, integers, rational. Match it up here, natural, whole, integer, rational. So J is the answer you want to pick. Next problem, number 3. So again, we have another number set question. It says, which diagram best represents the relationship among integers, rational numbers, and whole numbers? Okay, well, if I go back over to my diagram or look in my digital math notebook, I'm comparing my integers, rational, and whole numbers section. So my integers, rational, and whole numbers section. Integers, rational, and whole numbers section. So see how they are all together, one inside of the other. Okay, so keep that in mind, the relationship that they share. So when I look at these pictures, I notice on answer choice A, it's saying that integers is completely separate from whole numbers. And I notice the same thing similar on answer choice B. It's saying that integers is separate from rational. But when we looked at the picture, we saw that integers, whole numbers, and rationals are all within each other. So that would tell us that A and B are not going to be our choices. So we'll look closer at C and D. So in the original image, notice the whole numbers is within the integers, which then is within the rational number set. So we want whole numbers in the inside, then out to integers, then out to rational. So in the innermost shape, which would be this one or this one, we want the whole numbers to be the smaller innermost shape. This one says integers, then out to rationals, then out to whole. This one says whole, then out to integers, then out to rationals. So in this case, D would be the correct answer. Okay, moving along to number 4. On number 4, it says, if a number is a member of the set of whole numbers, then it must also be a member of which other set? So we're trying to see whole numbers. Let's look at our picture up here again. So if it is a whole number, then it is also considered an integer, and it's also considered a rational. So we either are looking for the answer choice that says integer and rational, or integer or rational. So one of those. Not natural is no, no. All right. So over here, we have integer as an answer, natural number, we already said natural is no good. Round numbers, that was just made up, and it is not a set part of all of the numbers. So the answer you would want to pick would be integers. Next question, number 5. Okay, so number 5 says, which of the following statements is always true? Okay, looking at the first one, it says all natural numbers are rational. So when I look back at my picture, all natural numbers, so here's my natural numbers, all natural numbers are rational. So think, is this natural numbers shape, all of that shape, is it within the rational big shape? Yes, it is. So that means that all of these natural numbers are in the rational number group. So that one is true, but, so that one's true. I would still always reread through the other answer choices, just in case. So this one says all whole numbers are natural numbers. So when I look back at my picture, are all the whole numbers, here's my whole numbers, are all of those whole numbers inside of the rational numbers? No. So the whole numbers group is a lot bigger, so that means that there's more numbers in the whole number groups that are not in the natural numbers. Okay, so that answer is going to be false. So that's a no, false. The next one says all integers are whole numbers. So again, all integers are whole numbers. Let's take a look. Are all these integers, notice the size of the integers, are all of those integers inside of the whole numbers? No, because integers include negatives and whole numbers do not. So all of your integers are not inside of your whole numbers. Okay, so that one is also false. And now the last one says all rational numbers are integers. Okay, last one there. All rational numbers are integers. So are all the rational numbers in the integers? No, they are not, because rational numbers include terminating decimals and repeating decimals, but integers do not. So all of your rational numbers are not in the integers. So that is also false, which leaves us with the correct answer. To confirm, A would be it. All right. Next question, number 6. What is the decimal equivalent of the fraction 1/5? So there are multiple ways you can do this problem. You can either scale it up, so that would be if you think of, okay, 1/5, looking at the denominator, oh, I can make that into 10. So 5 times 2 would be 10. So I'd have to do the same thing here. And I know 2/10 is written as 0.2 as a decimal. Or I can do my dividing. So when I divide, my little cowboy here set up, my cowboy sits on top of the horse, the cowboy goes inside of the house, and the horse stays outside. So I do my division, and the cowboy, which is the 1, will go inside, the 5 will go on the outside. 5 does not go into 1, so you put the 0, add a decimal here and bring it up, add a 0, 5 goes into 10, 2 times, so we put a 2 here, 10. Okay, so our decimal equivalent is 0.2. Next problem, number 7, says, what is 0.25 as a fraction in simplest form? Well, you need to know how to say the decimal mathematically, and that's 25 hundredths. So you would write it as 25 hundredths. That is not in simplest form, so you want to get rid of that answer. Now they end in a 5 and a 0, so that tells you you can at least start by dividing out a 5. That does not mean that's the largest you can divide out. You can at least start with that. So 25 divided by 5 gives you 5, and 100 divided by 5 gives you 20. Now again, looking at those numbers, ends in a 5 and a 0, so that's telling me I can still divide out another 5. So 5 divided by 5 is 1, and 20 divided by 5 is 4. So my simplest fraction is 1/4. All right, number 8. What is 0.7 written as a fraction in simplest form? Well, the 7 is in the tenths place, so you read that as 7 tenths. And then think, is there anything I can divide out of those? No, it doesn't end in a 5 or 0. They're not both even. It's not going to work, so that is it. That one is completely simplified. Number 9. Okay, which list shows these temperatures in order from coldest to warmest? Now, when you have cold temperatures, just think, if you thought of a number line, it's like a thermometer, okay? So if I have a number line, here's 0, 1, and so on. So there's that direction, negative, and then you go in this direction. So colder temperatures are going to be in the negative. So when I'm looking at my numbers, I want my negative numbers to come first. Well, when I look at answer choice A, I do start with a negative, but it goes a negative number, then a positive, then a negative, then a positive. So right there, you can't have a mixture of positive and negatives like that. That's not in order. So answer B, -5, -10, 0, 8. Okay, well, the negatives do come first, so that may be my answer. I'm going to leave that alone for now, so I can eliminate others if possible. Letter C says -10, -5, 0, 8. Okay, maybe that's the answer. And the last one says 0, then -5, then 8, then -10. Again, just like answer choice A, that's a combination of positives and negatives mixed together, so that's going to be out. Now looking more closely at these two. So I see the positive sides are both exactly the same, 0, then 8. So I need to look at my negatives. Well, notice on the negative side, the colder would be more to the left. So if I were to continue this number line, I would get to -5 first, and then -10 would be the farthest to the left. And if it's farthest to the left, that would mean -10 is the coldest temperature. So answer choice C would be my answer. All right, number 10. Which symbol makes the number sentence true? Well, 4 something -9. Now, what do my symbols mean? I have this one, I have this one. We know the equal sign, and then there's this one. Well, one of them's less than, one of them's greater than. In my way of remembering the less than or equal, this first one, I look at it as like a smushed L. So that smushed L makes the word less, so that's the less than. If I can remember that one, then the one that's in the other direction would be my greater than. But some actually do make this into a G. Okay, but if you can remember the L for less, and this last one would be greater than or equal. All right, so comparing 4 with -9. So thinking of the number line, okay, here's my positive numbers, here's my negative numbers. Well, 4 is on this side, so these ones are greater, these ones are less. So 4 is over here, -9 is down here somewhere, so actually 4 is on the greater side, so that would be our symbol we would want to put there. Picking answer B. Okay, last one. Which statement is true? So now if I'm comparing my values, they need to be in the same form. So the decimals is the easiest, but whatever works for you, go with it. All right, so I'm going to start with 1/3, and I need to change 1/3 into a decimal, and I do that by dividing. All right, so the cowboy, which is the 1, goes inside, 3 outside, and I would sit here and I would divide. Oh, let's take that off. All right, so that's going to be a 3, and I subtract, add another 0. Now if you notice here, it's repeating 3. So I've got 0.33 repeating. Now when I'm comparing, I'm going to go one number after the decimal place, one number after the decimal place, and I'm like, is 3 less than 3? No, they're the same. So I should go out another decimal place. So the next number, there's a 3. Now on this 0.3, there's no number after it. Hopefully you know that the 0 will be added on at the end. So let's compare these two. Is 3 less than 0? No, that's incorrect. Okay, so now let's go to the next one, answer choice B. 0.2 is already a decimal, so for 2/5, I'm going to go ahead and divide that. 5 doesn't go into 2, so you add your decimal and your 0, but 5 does go into 20 4 times. Okay, so this decimal here would be 0.4. Now I'm going to go ahead and compare 0.2 and 0.4, so the 2 and the 4. Ask yourself, is 2 less than 4? Yes, it is. So that might be my answer. Okay, always check through the other one. So I'm going to go ahead and do that. Letter C, 3/8. I'm going to go ahead and convert that. 3/8 will be 3 on the inside, 8 on the outside. 8 doesn't go into 3, so add a decimal. You get a 3, 24, subtract, add another, and that would be a 7, 56, subtract, and you would end with 0.375. Okay, so 0.375 over here, and 2/5 we already know from before was 0.4. Now very commonly, this number here is greater than a value like this because this one has more digits. No, if you do like I was showing before, look at each decimal place at a time. So looking at the first number after the decimal on each of them, compare just those. Is 3 greater than 4? No, it's not. So right there you can tell that C is not going to be the answer. So now when I look at this last one, all right, 1/5, turn it to a decimal, add a decimal 0. That's going to be 0.2. All right, so I've got 0.2 here, comparing the digit right after the decimal. That's a 1, that's a 2. Is 1 greater than 2? No, it is not. So D is not the answer. We can now confirm that B is correct.